Alright, hi everyone. You're welcome once again to MOG Economics YouTube channel. And today we are going to be looking at examples on the those cases we looked at in the last class. So on the Taylor series, how to use Taylor series to determine the relative extremum of functions. Now, so in this class, we're going to be seeing the real examples of those cases that we developed. So now, the question says that to examine the following functions or their relative extrema. This y equals into the bracket of 7 minus x all raised to the power of 4, and y equals into the bracket of s minus 2 all raised to the power of 3. So now, for the first one, now to test for stationarity, the first thing is we evaluate this function at 0, and then we need to know by evaluating this function at 0, it means we are taking the first order differentiation. So, and that is this. Okay, let's have something like this. So here, by taking the first order differential of this function, we have, using the power function rule, here this is minus 1, and then this differentiating the entire function here, we have that is minus 4 raised to the power of 3. So when we evaluate this result at 0, the value will be 7. So when this is set to 0, we have this drops out, and then our x is 7. So now the question is the value of x at this truly a minimum? We want to check if the value of x at 7 is truly a minimum or maximum. Is it a relative minimum or a relative maximum? This is 0 because here, if you take this out, dividing both sides by minus 4, that's 0. Or to even look at it this way, let's look at it this way. This s, for this whole expression to become 0, for this expression to become 0, this has to be 7, and that is why the value of s is 7. So if we substitute 7 here, we have 0, and everything, the entire thing becomes 0. So that's just it. So x is 7. All right. So now, to proceed, we need to test whether the value of x at this point is a relative minimum or maximum. We have to consider the higher differential of the function. So this is the first order. Again, the result for our first order differentiation is this. Now, differentiating this the second time, we have here again this, and let's first thing in the bracket minus 1. Then this is minus 4, 3. We have this 2. So at this point, we have 12. This times this times this 12. 7 minus x raised to the power of 2. Okay. And the third order. So again, we are differentiating this. So we have 2. Okay. Let's start with what we have in the bracket. This is 12. Then we have 12 times, and differentiating this one to 2 minus 1. So here we have minus 24 7 minus x. So again, let's differentiate. We have the fourth order differentiation, which is we are differentiating this again one more time. So here we have this. Differentiating the function itself. So this is simply 0. And then this whole expression is 1. And then we have minus 1 times minus 24 times 1. And that is 24. So here, so that looking at this value here, this last, the fourth differential, that means we have to differentiate up to the fourth. We need to have the fourth order differentiation for us to decide if this is a relative minimum or maximum. We have the derivatives up to the fourth order. So now what we'll do at this point is to evaluate each of these results at 7. So here for the first one, it is 0 that I've established. That's the first order condition. Then at second order differentiation, this at 7 will be 12 minus 12 into the bracket of 7 minus 7 squared. So this is 0 and then this is 0. For the third order, again to be 0. And substitute the value of 7 here. That means even at third order differentiation, this is still 0. The function evaluated at 7 is still 0. Now this, at this point, this is positive. The fourth order at this point is now positive. This is 24. So meaning, and this number here in this case is even. Now remember the other time when we were looking at those cases, we said that if this is even, then this can easily decide the value of is even and it is positive because the sign here is positive. So you can easily decide whether it's a minimum or a maximum. And this is because it is positive. Here the value will be a minimum because it is positive. So it means it is strictly convex. At least strictly convex. And this is what we mean by being strictly convex. Right. So with the like I said the other time, with the understanding of what we have done so far, I'd like us to take this as assignment and you just have to follow the same process. So, and if you have any question whatsoever, feel free to drop them in the comment section below. And also, in our next class, we're going to be starting with the concept of difference equation. Starting with difference equation, and then after that, looking at the differential equation. Alright, guys, see you in the next class.